Verify the trigonometric identity. Solution. So typically when we have trig identities and we're trying to verify them, we start by picking the more complicated side. So in this case, that's definitely the left-hand side. Let's go ahead and start by carefully rewriting that. So we have cosine x over sine x plus sine x over cosine x. And I think the best way to proceed maybe is to actually add these expressions. So the LCD here is going to be sine times cosine. So I'm going to go ahead and write that down. So this is sine x cosine x. This is the fastest way to perform the multiplication. So you know the LCD is just the product of the denominators. Then it's going to be cosine x, that's what's here, times, and then you look here and you ask yourself, what's missing down here in order to get the LCD? You're missing the cosine, so times cosine. So it's cosine times what's missing plus, and then sine. And then you look down here and you ask yourself the same question. What's missing here to get the LCD? You already have cosine, so you just need the sine function, so sine x. All right, this is going to be equal to, so cosine times cosine is cosine squared x plus, and then sine times sine is sine squared x. It's all being divided by sine x cosine x. And this is everyone's favorite identity. It's like the one identity that everyone knows. Cosine squared plus sine squared is equal to 1 all over sine x cosine x. Let's take a moment and see where we're trying to go. We're trying to get to secant x cosecant x. So the natural thing to do is to write this as a product. This is 1 over sine times 1 over cosine. And I did that because we want to end up with secant times cosecant. So 1 over sine is the same thing as cosecant. 1 over cosine is secant. The way I memorize these is it's the other letter. Sine has an S, cosecant has a C. Cosine has a C, secant has an S. So cosecant is 1 over the one with the other letter. Secant is 1 over the one with the other letter. And we're pretty much there. The original question said secant cosecant, so let's go ahead and write it that way. So this is really equal to secant x times cosecant x. And that's it. I hope this video has been helpful. We're being asked to verify the following trigonometric identity, so solution. A good rule of thumb when verifying identities is to start with the more complicated side, which is obviously this one. Okay, so let's write it down again. So cosine x over sine x cotangent x. Cotangent is cosine over sine, so this is equal to cosine x over sine x, and cotangent is cosine x over sine x. You can see these cancel, so you end up with cosine x over cosine x, and that is equal to 1. And that is exactly what we have on the right-hand side. So we are done. We're being asked to verify this trigonometric identity, so solution. So we'll start by writing down the more complicated side, and we'll show it's equal to cosine alpha. So 1 minus sine squared of alpha over cosine alpha. This is equal to, well, 1 minus sine squared, that's just cosine squared. So cosine squared alpha over cosine alpha. And so we just end up with cosine alpha. That's it. So we're being asked to verify a trig identity, so solution. This one looks pretty easy. In general, you can start by showing that one side is equal to the other side. And a good tip is to start with the most complicated side. So this looks more complicated, so let's write it down. So tangent theta divided by secant theta. And we have to show it's equal to the sine function, so maybe a good idea is writing these in terms of sine and cosine. That's usually a good approach. So tangent is sine over cosine, and the secant function is 1 over cosine. This is equal to sine theta divided by cosine theta. And when you divide, you're supposed to multiply by the reciprocal. So this is times cosine theta divided by 1. So the cosines cancel, and sure enough, we get sine of theta. We're being asked to verify a trigonometric identity solution. So we'll start by writing down the more complicated side, which is this one, and showing it's equal to 1. So sine squared of x times 1 plus cotangent squared of x. Okay, this is equal to sine squared of x, and 1 plus cotangent squared is cosecant squared of x. So this is equal to sine squared of x, and cosecant of x is 1 over sine x, but it's being squared, so it's actually just 1 over sine squared x. Sure enough, these cancel, and this is equal to 1, which is precisely what we have on the right-hand side. We're being asked to verify a trigonometric identity solution. So to verify an identity, one way to do it is to write down one side and show it's equal to the other side, and usually you want to write down the more complicated side. In this case, this is the more complicated side. So cosine squared theta times tangent squared theta plus 1. Okay, this is equal to cosine squared theta. Now tangent squared plus 1 is secant squared, so this is secant squared theta, which is equal to cosine squared theta. The secant function is 1 over cosine, so this is 1 over cosine squared theta. These cancel, and so you just end up with 1, which is exactly what we wanted. We're being asked to verify a trigonometric identity, so solution. One way to do this is to start by writing down one side and showing it's equal to the other. And usually you want to start with the more complicated side, which is this one in this case. So tangent squared gamma, we'll write it down, plus 1 divided by the secant of gamma. This is equal to, well, tangent squared plus 1 is secant squared. So this is secant squared gamma over the secant of gamma. And secant squared over secant is just secant. So we end up with secant of gamma, which is exactly what we want.
In this problem, we have to show that 1 plus cosine x over sine x is equal to cosecant x plus cotangent x. Let's go ahead and work through this. So solution. We'll start by using the more complicated side. So let's start by writing down the left-hand side. So 1 plus cosine x over sine x. And now we have to show it's equal to cosecant plus cotangent. So let's go ahead and break this up. This is really 1 over sine x plus cosine x over sine x. Cosine x over sine x. Sine x is cosecant x. It's 1 over sine. It's the one that starts with the other letter, but it's not cosine, so it's cosecant. And then cosine over sine is cotangent x. And that's it. We started with one side and we showed it's equal to the other side.
We're being asked to verify this trigonometric identity. So when you're verifying an identity, one idea is to start with one side and show it's equal to the other side, so solution. So if we start with cosine and we try to show it's equal to this, that looks pretty tough. So let's start by writing down this side. So cotangent theta over cosecant theta. And we have to show that this is equal to the cosine function. So I think the easiest way to do this is to write everything in terms of cosine and sine. So cotangent is cosine theta over sine theta. And cosecant is 1 over sine theta. Okay, so we have a fraction over a fraction. So this bar here, that means division, right? This bar right here. So it's going to be equal to cosine theta over sine theta times the reciprocal of this, right? Division means multiplying by the reciprocal. So times sine theta divided by 1. And looks like the signs cancel. So we just get cosine theta over 1, which is equal to cosine theta. So again, a good strategy is to start with one side and show it's equal to the other side. In this case, we chose this side because starting with cosine seems like a bad idea. It seems like it would be very, very difficult. In general, they say you should start with the most complicated side. That usually works. So we did start with the most complicated side. We're being asked to verify this trigonometric identity, so solution. So we'll start by picking a side, either the left-hand side or the right-hand side, and showing it's equal to the other side. Let's think about this. On the left-hand side, we have a fraction. So we somehow have to turn the fraction into subtraction. That sounds tough. On the right-hand side, we have subtraction. So we somehow have to turn the subtraction into a fraction. That sounds tougher. So let's try writing this down and maybe using an identity on sine squared. So sine squared x over cosine x. Well, sine squared is 1 minus cosine squared x. This is over cosine x. Right, the reason I chose this one is because I know an easy identity for sine squared, whereas here we would probably have to multiply by something and it could be messier. So let's see what happens. So this is 1 over cosine, so 1 over cosine minus cosine squared over cosine. So cosine squared x over cosine x. This is equal to 1 over cosine, that's the secant function, minus, and then cosine squared over cosine, that's just cosine. And that worked out really well. In this problem, we have to verify the trigonometric identity. So usually when you're verifying trig identities, you want to start with the more complicated side. So let's go ahead and do that. So the more complicated side is obviously the left-hand side. So we'll start by rewriting that. So we have tangent of x, parentheses, tangent of x, plus cotangent of x. Okay, so now I guess we have to multiply, right? We'll multiply tangent by tangent and tangent by cotangent. So let's go ahead and distribute. So tangent times tangent is tangent squared. And then plus, and then tangent times cotangent is just tangent times cotangent of x. Right, just distributing the tangent function. So this is equal to, well, I think we'll leave tangent squared as it is alone. And then cotangent is equal to 1 over tangent. So let's go ahead and rewrite it that way. So this is tangent of x times, this is 1 over tangent. Ah, look, they cancel. So this is equal to tangent squared x plus 1. And this is an identity that's totally worth memorizing. 1 plus tangent squared is equal to secant squared x. And that's it. We started with the left-hand side, and through some math, we showed it was equal to the right-hand side. I hope this video has been helpful.
Show that secant x minus tangent x times sine x is equal to 1 over secant x. So we're going to prove this trig identity, so proof. So what we'll do is we'll start with one side and show it's equal to the other side. Usually it's better to start with the more complicated side. So in this case, we'll start by writing down this side here. So secant x minus tangent x sine x. And we somehow want to arrive at 1 over secant x. So the natural thing to do is to write everything in terms of sine and cosine. That's usually a good idea. So let's try that. So secant is 1 over cosine. And then tangent is sine over cosine. And then we still have the sine function, so I'll leave it right here, sine x. Now we can go ahead and distribute this. So we'll have sine times sine. So this is 1 over cosine minus sine times sine is sine squared x. And we have over cosine x. Since the denominators are the same, we can actually perform the subtraction. This is equal to 1 minus sine squared over cosine x. Now, 1 minus sine squared, this piece here, this is equal to cosine squared. A really easy way to memorize that is to know that cosine squared is 1 minus the other 1 squared, so sine squared. And sine squared is 1 minus the other 1 squared, so cosine squared. Really cheap memory trick. It's 1 minus the other 1. So this is going to be cosine squared x over cosine x. And that's just going to be cosine. But cosine is equal to 1 over secant. And that's what we wanted to show. So that completes the proof. So I like to finish my proofs, little box with an x. So we verified the trig identity, but we really did went through a proof. So you start with one side, usually the more complicated one, and then you show it's equal to the other side. I hope this video has been helpful. That's
For this
it.
problem, we have to verify this trigonometric identity. Let's go ahead and work through it. So when you're verifying trig identities, you usually pick one side and you show it's equal to the other side. Let's start by writing down the left-hand side. So sine squared of theta, all being divided by cosine of theta. And the reason I picked this side is because sine squared is equal to 1 minus cosine squared theta. And that will give us the minus sign that we need to produce on the right-hand side. And on the bottom, we still have cosine theta. Now we can break this up using properties of subtraction. So this is 1 over cosine, or just properties of fraction subtraction. And then minus cosine squared of theta over cosine of theta. 1 over cosine is equal to the secant functions. We have secant theta, and then minus, and then you lose a cosine here, and you're left with 1 cosine up top, and that's exactly the right-hand side. We're being asked to verify this trigonometric identity, so solution. So one strategy is to start by writing down one side and showing it's equal to the other, and they always say that you should use the more complicated side. I'm looking at this and I've never done this before, but I do have an idea. Let's start by writing down this side. So cosine theta over secant theta minus 1. And we have to show that this is equal to this over here. Now you see here we have a tangent squared. And we know something about tangent and secant. We know, let me do it over here. So a side, we know that 1 plus tangent squared of theta is equal to secant squared. All right, that's what we know. So we know that tangent squared of theta is equal to secant squared of theta minus 1. And this is actually secant theta minus 1, secant theta plus 1. So here we have secant theta minus 1. So we're missing a secant theta plus 1. So maybe a good idea is to take what we have, so cosine theta over secant theta minus 1, and multiply by secant theta plus 1 over secant theta. Is this going to work? We'll find out. Is there an easier way? I honestly don't know. I've never done this problem before. So let's distribute in the numerator. So we end up with cosine theta secant theta plus, and then cosine theta times 1 is cosine theta. And in the denominator, we end up with secant squared theta minus 1, right? Difference of squares. We worked it out on the side, not part of our solution. This is equal to cosine theta times 1 over cosine theta, right? Secant theta is 1 over cosine theta plus cosine theta, all divided by, and we know secant squared minus 1, that's tangent squared. So we have that part. That part's good. And looks like we have the other part as well. This cancels, so you get 1 plus cosine theta over tangent squared of theta. Are we done? I think we should, for good measure, write exactly what we have here. So 1 plus cosine is really just cosine plus 1. It's all being divided by the tangent squared of theta. Verify the identity. So we have a trigonometric identity, and we're asked to verify it. Let's go ahead and carefully work through it. Solution. So when you're verifying trigonometric identities, it's usually a good idea to start with the more complicated side. So in this case, the more complicated side is the one here on the left. So we start by just writing that down again. So sine x, parentheses, cosecant x minus sine x. All right, good stuff. So now really the only thing we can do maybe is go ahead and distribute the sine function. So let's go ahead and do that. So sine times cosecant is going to give us sine times cosecant. I'm going to show all the steps. You can certainly skip some of these steps. And then sine times sine is going to give us sine squared. Good stuff. Now cosecant is equal to 1 over sine, so let's go ahead and rewrite that. So sine x times, and then 1 over the sine function. I always memorize it as it's the one with the other letter, and I know it's not cosine, so it's got to be sine, minus sine squared. So right, cosecant is 1 over the one with the other letter, so let me write it up here. So cosecant x is 1 over sine, right? It has the other letter. And then check this out. Secant x, it's 1 over the one with the other letter. So it's cosine x. All right, these cancel, so we get 1 minus sine squared. And so we're here. And so now we're at a point where we can actually finish. So this is actually something that I have memorized. This is actually equal to cosine squared x. And I'm going to show you how to memorize this identity in a second. But that's it. We did the problem. We started with one side, and we showed it's equal to the other side. So if you're wondering about this identity here, 1 minus sine squared equals cosine squared, the way I memorize that is as follows. So if you have sine squared x plus cosine squared x, and that's equal to 1, you can subtract cosine squared from both sides. So you do this, and you end up with sine squared equals 1 minus cosine squared. Likewise, you can subtract sine squared from both sides, and you end up with cosine squared equals 1 minus sine squared. So here's the memory trick. Sine squared is 1 minus the other one squared. Cosine squared is 1 minus the other one squared. At least that's how I am able to memorize it, and I'm able to do these problems. I hope this video has been helpful.